go through 6, 15, 16. Let me know if there's other ones we should go through. Thanks for finding my error on 13. All right, so number 6 was definitely tough. Now, is it supposed to be plus 10? Oh yeah, thank you. Yes. Right? Is it plus? Yeah. Okay. No, it's okay, I got it. All right, so we'll go through number 6. 6 was definitely a tough one because 588 is a very large number. So trying to simplify that radical, and the fact that 14 is the one they end up pulling out. I'll kind of show you guys a few tricks with number 6. Oops. So, if you guys were gone, feel free to do these with us to practice these. Let's see. And obviously there's video online as well. So we learned yesterday about our imaginary numbers. So anytime we're taking the square root of a negative, we can pull that negative out and make that I. So essentially, we're just simplifying the square root of 588. So there's an I out here. Now, if you have some calculators that you guys might have simplify radicals really, really nicely. If your calculator does that, it's fine. Like, these are awesome with simplifying radicals. But not everyone has those. So what we need to do is we basically need to figure out what goes into 588 and try to pull different numbers out that would be good numbers to try. So when we do this, kind of have to try, like I usually try perfect squares. I probably wouldn't have tried the biggest number possible because I don't know that I'd have been checking numbers like what 14 squared is. So when we're doing 588, we're just trying to find numbers that go into it. And when I'm talking about numbers that go into it, I'm talking about perfect squares. So I'll probably start there just because I don't know. So I'm just trying to see what goes into 588. So I'm just dividing it by these different numbers. And I think 49 goes into it. So I'm going to break this up as the square root of 49 times the square root of 12. And what I did was I just divided until it was a nice number. Square root of 49 is 7, so this becomes 7i square root of 12. However, square root of 12 can still be simplified. So if you stopped here, you're super close. You can go a little bit further though. The square root of 12 has a perfect square that goes into it. It's 4. So I can take this like square root of 4 out, which is 2. So this becomes 7 times 2i. So it would be 14i square root of 3. Again, if you have a calculator that simplifies the radicals for you, I would probably not give you a number as big as 588 like on a test to simplify. But that showed up on the worksheet, so I just didn't take it off. But it's kind of a brutal one, but trying to break it up and find things that go into it. Now you might have, I mean, I don't know how you would have known this, but 14 squared is 196, and so 196 goes into 588. So if you notice that first, that would be the most like efficient way. But I don't know how you would know that other than like having some sort of calculator that simplifies it for you. All right, so we'll go to number 15, which these 15 and 16 both very similar to one another. We need to get that I out of the denominator, because we learned that I is essentially a square root, and we can't have a square root in the denominator of a fraction. So I need to get rid of the I, and so what we use is we call it the conjugate. It's the opposite version of this. Whatever I do to the bottom, I have to do to the top. So I'm trying to simplify the bottom. I don't really top, like in terms of like what's up there, but I'm gonna end up having to simplify that as well. So I have the FOIL up here. The FOIL on the bottom. The bottom is a lot nicer. Because I know the bottom, I chose that conjugate because of the fact that I knew it would cancel. So on the top up here, the 5i and 4i can combine, that's going to be 9i. But then we also learned that I squared equals -1. So anytime I see I squared, I'm going to put -1 in place of it. So wherever I squared is, I put a -1. And you don't have to show all these steps. If you're able to kind of skip over a little bit, that's fine. This becomes a -2, so this is 10 minus 2, so 8. And then this is 4 plus 1, so that would be 5. And this is what we wanted. We wanted no i's in the denominator, so we got rid of that. And we're going to do the same thing for number 16. But number 16, if you didn't get that one completely correct, you might not have noticed there was some simplifying you could do at the end. This one was kind of a unique one, that it ended up being able to simplify more than this one was able to. So again, we're going to use our conjugate, which is 3 plus 2i. It's just always the opposite sign. Whatever I do to the bottom, I have to do to the top. So we're going to FOIL. And if you notice those middle terms cancel without having to write them, I'm fine with that. So you don't have to write that if you don't need to, like if you notice that already, that will always happen. Again, the I squared, so I'm going to replace those with -1. I'm going to combine some like terms up here, so kind of a lot going on here. So 8 minus 21 is a -13. And then I'm going to put that -1 in there. I have 9, minus 4 times -1. So this becomes 12 plus 14, so that's going to be 26. And then 9 plus 4, so that'll be 13. Now you could notice that both of those could be divided by 13. You could factor a 13 out, however you guys want to do it. You're distributing that 13. 26 divided by 13 is 2. 13 divided by 13 is just 1, so 1i. So that does simplify more than like the previous one. So if you stopped at the previous, like at this step, you were super close, just didn't notice you could simplify further. So kind of a unique one in that case. All right, so like I mentioned yesterday, we kind of had to make a left-hand turn out of chapter 5 and move into chapter 8 just because of time's sake. Just with talking with Mr. Hatfield about what we have to get covered this semester. So chapter 5 and chapter 8 I ended up kind of combining, but you're going to notice that we're not doing a ton out of chapter 8 either, so it kind of wasn't a bad thing that we put these two together, because we're actually only going to do 2 more sections out of chapter 8, so today and then tomorrow. So that means we're going to review and then test, or quiz, or whatever you want to call it. So yeah.
Do we have a shortened class because of the assembly?
So tomorrow is not shorter, you just don't have AR.
Oh, okay.
Thursday is going to be shorter because of the Veterans Day assembly.
Okay.
So that's our review day. We'll kind of see where we're at, but I think we'll be okay. So my plan is Friday test, I'm thinking. But hopefully you guys are confident about what we've been doing, or that we'll get there if you aren't already. Now today is going to seem really, really similar to what we've talked about previously with the zeros of a function. And this is kind of the last 2 days we're going to be seeing the zeros of the function. So this kind of is stuff we've talked about before, adding a little bit of new stuff in. So this shouldn't feel brand new to you guys.
It's, but you have to, it's 24, 24, 5, and then which is because it's all so it's hard to explain. And then it's 6, and then it's go like from 4, and it's go like 6.
Oh, the exponent ones? Is that what you're doing? Yeah.
I don't know how to explain it.
So,
No, she's a teacher. And I just think
that's what you want to go to school for,
no. No. Yeah.
You're not a budding math teacher. What?
yeah, I can tell. I think I could make it into 2. Yeah, because he's a genius. Yeah. I keep both types of calculators on one, so I can. I have 2 calculators. One for like simplifying radicals.
It's not the worst idea. I do calculator thing. Yeah.
Because
I did mine that for a while. Because he never had a calculator.
because it's just way faster than like actually doing it.
That's what you want to play.
I don't know why they don't like
brain.
well, you know what? I think smarter, not harder. I mean, working.
You what?
Okay.
Miss Donovan,
Yeah.
how was it those?
It was fun. It was
Did you
fun.
get Garrett your pass?
No, I don't think Garrett needed it.
No.
Yeah, he's broken.
I just wanted
They were pretty easy going about the passes though, because like Peyton cut
Oh,
his
I
off for
didn't
the
pass.
game. Yeah, and
I
like
didn't have to pass all weekend, and I said,
no, I kind of wondered. I never
don't
had
get-
anyone look.
they don't get paid enough to worry about.
Yeah, they're probably just like.
Well, after the
should've
first day, I
just,
got my car.
What?
I got my pocket.
I should have just left in my car.
Yeah.
Yeah, it was good.
Dude, you know Jackson only had to
Yeah.
I don't understand why I stayed there. But.
All right. So we're trying to find the zeros of the polynomial, and basically these just mean we're solving these. And again, hopefully you remember this a little bit from last. I think it was last chapter, last semester, which was like 2 weeks ago. So, but both of these have 2 answers. So if you only got one, there's probably a second answer there. So take a minute to try those.
Let's go outside today.
Yeah.
It's nice out.
I think it's very
I think it's probably the last nice date for a while.
Yeah, that would be great. And letter D.
What?
Letter D.
I think we go back. It's hard enough to list this.
Actually, I want to, yeah. Example 2.
No, what was that?
Okay.
Yeah. Letter D seems good.
All right. So to find the zeros of the polynomial, what you guys do in example 1?
Yeah, it's 5x.
What's
I took an X out.
I would take an x out. So I would have factored on this one. To move the 5x over, I think you're kind of getting yourself into like kind of some weird stuff going on there. So we want to take the x out.
Well, once you have 5x, it's pretty obvious.
And then at this point now we can set those equal to 0 to solve. And this is how we get 2 answers. We could find out that x could equal 0. But then x could also equal 5. So we get 2 answers. Those are our zeros of our function. We will be using this more today, but we'll get into a little bit with imaginary numbers as well with it. How about example 2? There's probably 2 different ways you guys can do it.
At 9.
Add 9. Okay, yeah, we'll talk about that in a second. I would argue that factoring probably, you end up with less mistakes because of the fact that you might forget your second answer in this case. But long as you remember that the square root of 9, since we put the square root in, we need both answers. So we need a positive and negative 3. If you did it this way,
So which way do you think is better? Wait,
I'll say that.
who's your favorite kid? Alright, so either one is fine.
She literally just told us that
Who
she
got
like
the answer
factoring
first?
it better.
Who got the
Who
answer?
got the first one wrong?
Who got the answer first?
Did you have both answers?
Yeah, I had 3 and negative 3.
Good job.
Yeah.
Alright.
Dude, I was looking at
It's not that hard.
I was looking
No,
at
it's
pictures
not.
from
Sorry.
last season and you were tiny. That was so funny.
Okay, so what we're going to talk about today is what happens when there's going to be times that an answer will actually repeat as an answer. It's kind of a strange situation here, and I'll try to kind of show you guys how that comes up. Is if these are all zeros. Sometimes x equals 5 could be the answer twice, or x equals 0 could be the answer twice. Kind of strange that that can happen. So when a solution repeats more than once, so and I'll kind of show you guys a pretty basic example of this. This is extremely important when we're graphing to understand what's going on in the graph. But I'll try to show you guys a quick little example of where this comes up. So if I have, let's just change the top problem to be, instead of second power, let's make it the fourth power. So let's change the warm-up question to look like this instead. So what would you take out in this case? What's that?
X
X cubed,
cubed.
x to the third power, because we could take that out because it's common. We'd be left with x minus 5. Oh, that's not a very, well,
It's fine.
yeah, it's fine. All right, so anyway, so x to the third power, really what that means is it's x times x times x, right? So if I really wanted to solve this and tell you guys all the answers, I could say x is 0 and 5. However, really x is 0, that would have a whoops, not 3. X is 0. We'd say it has a multiplicity of 3. Because it technically is repeating that 3 could happen, or 0 could happen 3 times in this problem and be okay. Now typically we wouldn't write that, we wouldn't really care about that. I just want to know the answers. X is 0 and x is 5. However, again, if we're talking about graphing, do you think these two graphs would look the same? No. The one should have a lot more going on than the other. They might look similar, but that multiplicity of 3 makes that graph change the way it looks. So these actually would end up being very different graphs. And kind of quickly to show you, I'll pull up my, and I didn't graph these ahead of time, but so you guys can see just that understanding that they have a pretty different outcome, I think. Now that I say that, they'll probably look super similar and not be very interesting, but. Oops, too many. And then this one, we'll do x to the fourth, I think, minus 5x to the third. Oh gosh. That's you. likes to like hold on the same button. It works much better on my Calc on my laptop, but I just don't feel like walking back there. All right, so hopefully these graphs look different enough to show you guys that. So there's our first one. What's that second one doing? All right, so pretty different graph. Like obviously they're not super different because they have things in common, but the fact that 0 repeats, it's like there's more going on there than just there being a 0 and a 5 as our solutions. So we get a different shape to our graph. There's more, like obviously the minimum's gonna be a lot further down. So it is important to understand that just having two of the same answers, that multiplicity does change these graphs quite a bit. So that's what we're talking about today in terms of finding our solutions, but also finding that multiplicity. So I'll give you guys a little bit of time to find some of these zeros, kind of give you guys a chance to do that. Feel free to check with one another. Stop the video while they're working.